All right, so back at it with our lesson 4 of Unit 8 on page 101. And what we're going to do today is look at three trigonomic relationships. All right, and you can see this takes care of 19.1 and 19.2. I can find side lengths and angle measures of triangles using sine, cosine, or tangent. Now, sine, cosine, and tangent are three specific ratios in right triangles and only right triangles that we use, all right, to find missing side lengths and all right, missing angles. All right, so if you would, go ahead and pause the video, do the opener here, and then we'll talk about how that's related to our trig ratios in just a moment. All right, so what do you notice about the relationship between these three triangles? All right, so when we look at this, all right, and we look at the ratios, right, we get 12 to 24, we get 10 to 20, we get 8 to 16, right? So all three of those ratios, all right, are equal. Those are all 1/2, right? And what we know is they all three have right angles. They all three have this angle marked as congruent. So really what we know is all three of these angles, or excuse me, all three of these triangles are congruent by angle, angle. Not, I said congruent, so let me try that again. All three of these triangles are similar, excuse me, by angle, angle. All right, and if we know that triangles are similar, we know that the ratio of their sides, right, will always be the same. And that's what's going to happen when we do our trig ratios. They're all based on that any triangle we have, all right, with the same angles will always be similar, all right, no matter what those angles are, especially if we're in a right triangle, right? Because we know that if we're in a right triangle, we automatically have one congruent angle because they're all going to have a 90-degree angle. So once we get another angle congruent, right, no matter how big or how small, all right, those triangles are, the ratio of any two sides of that triangle will always be the same, all right? And you can see that from what we have up here. Now, we have three different ratios that we're going to look at, right? So we're going to look at sine, and we're going to look at cosine, and we're going to look at tangent. All right, now what we do is we do abbreviate when we look at them in a triangle. So we are going to say that the sine, and we abbreviate that as sin of theta, and theta is usually the symbol we use for angles, is always going to equal to the opposite side over the hypotenuse. All right, and I'm going to go through and talk about exactly what that means in just a moment, but I'm going to give you the three ratios so we can talk about that, right? So cosine of theta is going to be the adjacent side over the hypotenuse. All right, and then tangent of theta, all right, is going to be equal to the opposite side over the adjacent side. All right. Okay, so those are our three ratios. Now, and what we say here is that perspective matters because the opposite and the adjacent change based on which angle you're looking from. The hypotenuse is always the hypotenuse because we know the hypotenuse is always, no matter what, the side opposite, right, the right angle. So we know that's the hypotenuse every time. So what changes is what is my opposite side and what is my adjacent side based on which angle I'm looking from. So notice if I'm at angle A, right, the opposite side would be BC, right? So if I look from angle A, that the opposite side is BC. The adjacent side would be AC. It's the side that is touching angle A. All right, but notice if I'm looking for B, all right, if I'm looking from B, AC is now the opposite side, and BC is the adjacent side. Okay, so just remember that the opposite and the adjacent depend upon which angle you're looking from. And it doesn't necessarily matter which angle you're looking from. All right, you can set up whatever ratio, all right, is true from that angle, but you have to know what the opposite side is and what the adjacent side is. And then you'll always hear a lot of SOHCAHTOA, right? SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over adjacent. Now, for some of these problems, all right, you will need a scientific calculator that has your trig function. So, and I'll show you on my calculator how to access those and what to do. Okay, so now when I look at this problem, right, we want to find all the trig ratios for angle B. All right, so notice for angle B, all right, that's right here. I don't know that angle, right? So this is 30, this is 90, so I know all the angles in a triangle add up to 180, so I can say that this is 60. All right, and so if I look from angle B, or from the 60-degree angle, I know AC is the opposite side, and I know AB is the adjacent side. So if I think about sine of angle B, that would equal to the opposite side. So the opposite side would be AC, over the hypotenuse, which would be 16. All right. The cosine of angle B, all right, okay, is going to be the adjacent to the hypotenuse. Now, the adjacent this time is AB, but the hypotenuse, notice, is still 16, right? Because the hypotenuse is always the same. And then my final here for angle B, all right, is tangent. And tangent is the opposite. So the opposite is AC. And the adjacent, once again, is AB. All right, so that's how we look at those, right? And so just to kind of give you a quick peek here, so if I did the sine of angle C, right, the sine of angle C would be opposite. So now notice the opposite for that would be AB, but the hypotenuse is still 16. All right, so once again, that trig ratio, all right, just depends on, all right, what angle you're looking from. All right, so we just wrote all those trig ratios. So now let's actually look at a few problems, all right, and talk about how to use your calculator. So we'll do problems 3, 4, and 5 here. So notice, all right, I have this angle is 54 degrees, right? And I have my 90-degree angle, so that means I can use my trig ratios because I'm in a right triangle. And then I have this side and then W. So notice we know right away that 17, right? 17 is the hypotenuse. Now, if I'm going to use this angle, which is 54, I have the opposite side, which is W. Right, so I have the opposite side in the hypotenuse, all right, which means we want the sine, right? The sine of an angle is opposite to hypotenuse. So I would say the sine of 54 degrees equals the opposite side, which is W, over 17. All right. Now, this sets up an equation. Now, what I want you to think about is that the sine of 54 degrees is a number. So that's like, it's going to be a decimal number, right? But it's a number. It's a single piece here. So we're going to keep this all together. And the reason we're going to do this is so that we can get an exact answer at the end. So I'm not going to find the sine of 54 right now. I'm going to wait till the end and put it all in my calculator at once. Now, what I am going to do is make this a proportion because sine of 54, all right, is over 1. And then we know that if we have a proportion, we can cross and multiply, right? So W times 1 is just W. And then 17 times the sine of 54 is just 17 times the sine of 54, like that. And the reason why I want to do this is because it is going to give me a decimal answer, and I want to be as exact as possible. So I don't want to round in two different places. So now, when you look at your graphing or your calculator, right, you should see sine, cosine, and tangent somewhere on your calculator. Now, the other thing is notice that we are in degrees. Now, there should be somewhere on your calculator, like on mine, if I go to mode here, you can see that I have a choice between radian measure and degree measure. And so you want to make sure that the degree measure is highlighted. Now, on some of the other calculators, I don't know that I have one of the other scientific calculators in my office here, all right, but you'll normally say DEG, all right, at the top, all right, and that's how you know, all right, that you're in degree mode. And the reason is now what I want to do is just type this in all at once, so 17, and then sine of 54, just like it looks like on my paper, and then I hit enter. And so what that tells me is that W, which is that missing side there, is 13, and we'll go with two decimal places, 13.75 units long. All right. And so we know that we can set up these ratios because no matter what, all right, we know that we're going to have similar triangles. Those ratios have to be the same no matter what triangle we're in. All right. So this sine of 54 is that ratio, right? So it's giving me that ratio as a decimal. All right. It used to that you'd have to look those ratios up in a whole table, all right, to go through and use them. All right. So but now we have our calculators. All right, so let's look at 4 here. So when we look at 33 here, right, once again, we see 4.5. All right, that's across from that, so we know we have the hypotenuse, but notice this time. So the side opposite 33 is this side. Well, W now is the adjacent side. So I have adjacent, and I have the hypotenuse, so that would be cosine. So cosine of 33 equals, all right, the adjacent over the hypotenuse, just like that. All right. And so now, once again, we can cross multiply here. So I would do W equals, and that's going to be 4.5 times cosine of 33 degrees. And then once again, we're just going to type that into my calculator, or your calculator, 45, and then cosine of 33, like that. And that means that that side is 3.77 units long. So W equals 3.77. And then we'll do one more here. All right, and if you can guess, we've done sine, we've done cosine, so this will be an example, all right, of tangent, because if I look at 25, notice this time I have the opposite side, which is 10, and the adjacent side, which is x. All right. So now when I think about it, tangent of 25 is the opposite side over, all right, the adjacent side. Now, once again, we're still going to cross multiply, but notice the difference here. So when I cross multiply this time, I'm going to get 10 times 1, which is 10, and then I'm going to get x times tangent of 25. So x times the tangent of 25. Now, once again, this is a number, right? And so if you had 10 equals 2x, you would divide both sides by 2, right? And you'd say 5 is equal to x. Tangent of 25 is a number, just like we have a 2 here. So I'm going to divide both sides by tangent of 25, just like we did over here in the margin. And then once again, I can just type that into my calculator, right? So 10 divided by tangent of 25. And then that side length is 21.45 units long. So that's how you set up your trig ratios and solve. All right, for side lengths. Now, let's drop down to the page 101 here. All right, and let's talk about finding angle measures. So the good news about finding angle measures is you set up the ratios the same way. All right, what happens and what's the difference is at the end when we solve for that angle. So when we think about this, right, we need to undo things, right? And so when we undo addition, we undo that with subtraction. We always have opposites and inverses in mathematics, right? I undo multiplication with division. All right, and so these are called inverse operations, right? They undo each other. And so every operation in mathematics has its own inverse. All right, so when we're solving for angles, all right, we're going to use an inverse trig function. All right, and so for example, I want to find the measure of angle P over here. Well, here's angle P right here. And so notice I still set up the same ratio. So angle P, and then I have the opposite side of 41 and the adjacent of 100. So notice this means it still would be tangent, but notice I don't know the angle. So I'm going to put in angle P. But I do know both sides now. So it would be the opposite over the adjacent. All right, so now here is the inverse. All right, and I'm going to show you the long way. And so basically what's happening now is that we're going to take the tangent inverse of both sides. I'm going to write it out here. Now, you don't always have to write this step, but I want to show you what we're doing. All right. So we're taking the inverse, and this is when you put this little -1 here, that means the inverse. So tangent inverse and tangent undo each other like square and square root, adding and subtracting, multiplying, division. They undo each other. And so we are really doing this to both sides, and we get angle P is equal to tangent inverse of 41 over 100. Now the reality is you can skip from this step to this step if you understand what's happening. But I wanted you to see this, right? Because it's the same idea when we have x squared equals 53, right? To solve that, you would take the square root of both sides, right? The square and the square root undo each other, and that gives us x equals the square root of 53. All right, and that would be your answer. But a lot of times, you don't show this step. Sometimes people just go from x squared equals 53 to x equals root 53. They don't necessarily show the inverse undoing. And that's usually what happens here. We normally go from this step to this step. Now, on your calculator, all right, so you can see your trig functions, right? Sine, cosine, tangent. And you can see right above them here, sine inverse, cosine inverse, and tangent inverse. All right, so the inverse functions are the same keys usually on your calculator, but you have to hit second to pull them up. So notice I want the tangent inverse of 41 over 100. So I'm going to hit second tangent inverse, and I'm just going to type in whatever ratio I have here. And that tells me that angle P is equal to 22.3 degrees. All right. And so each ratio has an angle associated with it. And once again, because that's all coming from similar triangles, right? So if everything is similar, when I have a ratio, right, there's an angle associated with that. All right. And so your calculator is programmed to recognize that. All right. So let's flip the page and let's just do one more. All right, to find an angle measure. All right, I'm going to jump to number 8 here. And so notice we want to find this angle here. And once again, we have to think about what ratio do I have? Well, I have the hypotenuse again. And notice this time I have the adjacent side. So that is a cosine ratio, right? So cosine of my angle is equal to my adjacent side over the hypotenuse. And then once again, to find my angle, I have to do my inverse function. Right, so I'm going to say x equals cosine inverse of 3 over 5.8. And then the nice thing, once again, is you can just type that directly into your calculator, right? So second cosine inverse, right? And then I can just type 3 divided by 5.8. And the nice thing about that, once again, is there's no rounding involved. You're going to get a better answer, a more exact answer. And we can see that that's 58.85. And remember, we're solving for an angle, so that is degrees. All right, so there's your introduction to trig functions, all right, finding sides, finding angles. All right, go ahead and finish up this lesson, and I will see you next time.